The purpose of doing titrations is to determine the unknown concentration of a solution. An acid-base reaction is a double displacement reaction. You can also use redox titration reactions to determine the unknown concentrations. Before you actually begin, you need to clean your glassware by rinsing it with distilled water. You do this so there are no contaminants in your experiment. You should also rinse your burettes with what you are putting in them so that there are no contaminants in your reactants. If you do not do this, your experiment could yield bad data. To do this, you should pour it into the small beaker and then pour it into the burette. It will make life so much easier if you do that.
Once all of your glassware is clean and ready to go, you can begin to prepare your unknown. It will consist of, in this case, the acid of the unknown concentration, some distilled water, an indicator. Indicators are just things that change colors when there is a change in pH. You use these to know when you've reached your equivalence point. Since your acid concentration is unknown in this case, your indicator will be the phenolphthalein. If you were titrating a base, you could use something like methyl red. A list of possible indicators are shown with their pH range on page 580 of your book. You normally stop titrating when the solution only changes color slightly. Only slightly though. Any more than slightly means that you've titrated too much and your calculations will be off. So to prepare your unknown, get a clean flask of some sort. Go to the burette that is housing the solution of the unknown concentration. Record the amounts of solution in the data tables before and after you pour some into the flask. Make sure you read the burette correctly, looking at the bottom of the meniscus and getting 2 decimal places with this burette. You can use a color card for the background to make the marking easier to see. This is so you can calculate the actual amount used since burettes measure the amount of stuff delivered. Only use like 5 to 10 milliliters. You don't need that much. After that, add enough distilled water just so you can see the color change better. After all that, add 2 to 3 drops of your indicator into the flask.
To begin titrating, take your flask over to the burette with the acid or base of the known concentration and put the tip of the burette in the flask. Record the beginning amount on the burette in your data tables. Before you begin, be sure to use your fine motor skills in your hand. It is the proper way to titrate. Twist the knob with the insides of your fingers instead of your fingertips. You do it like that because those are your fine motor skills. Keyword fine. Now begin titrating by turning the knob and letting the solution flow into the flask. While you're doing this, you need to constantly swirl the liquid in the flask to help mix everything together completely the whole time. It is very important that you do this. You should start to see color appear and disappear in the flask as you keep going. Once the color is more persistent, you should slow down the flow to drip slower and slower until you see the slight color change. When you're done, be sure to record the final amount in the burette in your data tables to calculate the amount used later on. If you screw up, just prepare another flask and do it again. You should get at least 3 good and consistent trials. You should be able to wash most of what you're using down the drain with lots and lots of water. If you're going to use a flask again, be sure to rinse it with distilled water and not regular tap water. To clean your burettes, always drain it and rinse it with distilled water. If you don't, sometimes solutions can crystallize and clog the burettes. When you rinse it with distilled water, you should always drain it, at least some of it, through the tip while turning the knob every which way to be sure nothing is left there to clog it. Rinsing everything twice is never a bad idea.